Hi, I'm John Lee. I'm passionate about science, physics in particular. Okay, now what we've got here is quite a bit of chemistry and there is a lot of physics involved. Things like colour is all about physics, the frequency of light being that of colour. Now, as with my stage 5 kids, we've been looking a bit at the history of the structure of the atom and how, like the alchemists in the Dark Ages in Europe were trying to turn lead into gold, and they tried doing all sorts of mixing things. So they have things like where you could mix two chemicals together, where you have two waters, you mix them together, and voila, you've got this different colour. Okay, now this was actually a dye that they found out. This is sodium iodide and lead nitrate. So it makes up to be lead iodide, which is the yellow they used in dyes like Leonardo da Vinci used to use it in his colours. Okay, so here's another little, and they used to use a lot of magic, but they used to have to be careful with their magic or they get their heads chopped for being like witches. So here we've got another couple of clear liquids. Okay, I'll pour one liquid into the other. Oh, look at that, changes colour, beautiful colour. And the chemistry, they came to call these things where they would turn into indicators. So look at that, so we keep pouring. It's like magic, but it's not magic at all. It's not magic, it's chemistry and to do with colours. And this is one of my favourites. This is a rainbow. This is what I call the rainbow colour. Okay, and this one here, this is amazing. I love this one. This is one of my favourites. If, say, I just add some of this one here, watch what happens to this one here. Okay, I go around in a clockwise direction, okay, with these beautiful bits of equipment, and look, you automatically, just from one drop, you get a colour change. Look at this. So we go around in a clockwise direction, get these beautiful colour changes. Look at that, all the way through. It goes through all the way through to if I add a little bit more, it'll go through to a lovely purple colour. So it actually goes through all the colours of the rainbow. It's quite spectacular, which is physics, different frequencies. Or I can even go the other way. So if I take this other substance, this other clear liquid, and hopefully some of you guys have already covered this, if I go around the other way, so we go around anti-clockwise, what happens is we can go back different colours. Okay, it might need a bit more, this one mightn't be quite strong enough. Okay, and we go back, we're getting back to, well, this one's not strong enough, I might have to pour it in. It's supposed to go back to a rosy red. I'll pour it in, that's what I'll do, because I don't think it's quite strong. Still go around in that anti-clockwise direction. And look at that, we go back to this nice rosy red colour. Isn't that pretty? This goes through all those colours of the spectrum. It's pretty amazing. That's rainbow. I love that stuff. Rainbow one. Okay, now the other one we were talking about with our guys, when we were talking about those 4 elements the Greeks used to talk about: air, water, fire and earth. In that movie the other day I showed you, there's that one where they talked about different types of air. So different types of air. So what this is a gas jar, okay, so it can capture different types of air. Okay, and what I'm going to do here is I'm going to put in this stuff here that is manganese dioxide, and this just acts as what we call a catalyst. So it's not actually involved in the chemical reaction. If I just put, doesn't need to have much in there, let's put a little bit of that in there, and what I have here is hydrogen peroxide, which is simply water, but it has an extra atom of oxygen. So when it goes and reacts with this, it'll turn into water and it'll release that oxygen. So what we're going to do here is, I'll just put it in here and put the lid on and try and catch that oxygen. Pop that in, put the lid on, there he is bubbling away. So with the chemical reaction you see the bubbles Anything that's bubbling, oh, and I can feel it's that strong, it's pushing the lid off. So that's definitely filling up with oxygen. How do we know it's oxygen? There's tests you can do. Okay, so oxygen's involved in combustion. How do you smother a fire? You deprive it of oxygen. Okay, so how we can test for oxygen, it's what we call the glowing splint test. Glowing splint test, paddle pop stick, set it on fire. Flame, 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 put that one back to the safety flame, blow it out, let it glow, and let's see what the oxygen does. See that? Bursts into flaming it. That's what the oxygen does. Good test for oxygen. The glowing splint test. Okay, now, for those of you who I've already taught, what I've got here now, we can have the lights out. So we can have some, I'll turn the lights out. Okay, now what we have here, I've got these 5 little dishes here on their heat mats, and I've got some various salts. So with my class this week, we're looking at salts. Now remember, a salt, not a salt, like I'll hit you over the head. It's a salt, not that sort of a salt. A salt, being like sodium chloride that you put on your fish and chips, is a metal and a non-metal. Okay, so for example, this one was sodium iodide mixed with lead nitrate. Okay, so it's a metal and a non-metal. And what I've got here are various metal carbonates. Now what we can do is, the fantastic thing about this is where how you can see different colours in the atom. So we're talking about the metals in each of these. So I've got various metals, and I'll show them to you as we go through them. And what they do is, I just react it with a bit of acid, and what it'll do is, this is where you can have a look at them with these spectroscopes there. So if you want, you can have a look at them through the spectroscope, and what you see is you'll see the different, what we call spectra of the elements. And this is how they can tell of the different elements that are in the starlight. So the colours from the stars. Okay, so let's have a little look at this one. So I'll just get it bubbling away, and then we'll add a flame to it and see what colours we get. 4 and okay, so look at this. So have a look at the colour. Okay, so it's a pretty orange colour to that. Okay, pretty orange colour. That's pretty nice. Okay, so that one is sodium. Pop the lid on. Okay, this one is calcium. Let's have a look at the colour of calcium. Okay, to get pretty old, being generous. Put a nice little hit in there. A generous amount of this. Acid, bubble, boil and trouble. Macbeth, the witches around. Now look at that pretty colour. Now there's your pretty colour. That's the colour of calcium. Lovely pretty colour. It's like an orangey red. Nice, pretty. Okay, next one we've got here, lithium. What's the atomic number of lithium? 3. Very good. Okay, let's have a look. Lithium. What colour will lithium be? Green.
Red. Coke.
You can keep guessing. And it's actually, it has all these different colours attached to it. Like we all know the green. Oh, look at there, look, that's quite a nice one. Pretty pinky red one. Okay, that's pretty colours. They're all pretty. I think they're pretty. Okay, here we have nickel. Which one has leaving their notes? I want to scrap this one. Okay, scrap the nickel, we're not doing that one. Okay, now this one here. Okay, now this is copper carbonate. Yeah, now, and I remember as a kid, I used to throw, like in campfires, throw things in campfires, watch the colours, and the magazines put out this green colour. And that was a lot about the copper that they would use in the inks in magazines, glossy magazines. Okay, so this one should be pretty green. Let's have a little test of that hypothesis. There, look at that, pretty green. Green, you can see it around the edges. Okay, so that's pretty good. There's just some pretty colours. That's just some good examples of the things we can do in chemistry with different colours. Okay, and then what we do, we're going to do different tests for the different types of air. So oxygen has the glowing splint test. Okay, you may have done the pop test for hydrogen. Yeah. Okay, and that's what they call explosive air. Okay, I had carbon dioxide, they call the heavy air. So I filled up a balloon here. Okay. Now you guys might want to stand back a little bit because this is... You might want to cover your ears. It's very quick. Okay, let's have a look. Pretty good. Grand finale. Thank you very much. Okay, that's it.